Yeah, of course. So we're going to be graphing lines in slope-intercept form today. For the last, I don't know, 7 or 8 days, we've been really building up to this lesson. I was hoping to provide you with some intuition through those various handouts involving tile patterns and whatever else we looked at with patterns, so that you'd be able to more easily adapt to graphing in what's called y equals mx plus b form, which is something you need to memorize now. So we've got this form of a line. It's not the only form of a line, but it's probably the most useful and easiest to use form. Cheyenne, are you taking notes? Close. So y equals mx plus b. You can't take notes in that. You need paper. Okay, so y equals mx plus b form has the slope and the intercept. We looked at how that related to the tile patterns yesterday. We're just going to get completely away from patterns today and just go for it. So here's 3 lines. They all look just like mx plus b, right? So we're going to use the slope and the intercept and graph them. And then we're going to take it a little further. So first line. So you want to do these separately. So we'll go for 1, 2, and 3. Which one of these numbers was the y-intercept? Can you guys remind me from yesterday and the last couple days? Was it the 3 or the -6 where it crossed? The 3 was the growth factor. -6 is the spot that it crosses the y-axis. So this one starts down here at -6. This tells you how much to grow. The slope, though, we're going to start thinking about today, all those examples we saw before had really simple slopes. We're going to start getting away from things with extremely simple slopes today. So a slope is always composed of 2 parts, the vertical part and the horizontal part. I don't see 2 parts here, do you? I just see a 3. Where's the other part? 3 can also be written as lots of other things. One of those things is write it over 1. We saw that yesterday, right? So the vertical part, if you remember from yesterday, is the top. The horizontal part is the bottom. In slope land, we call this rise over run. So this guy rises 3 and runs 1. So we're going to go from that y-intercept and rise 3. 1, 2, 3, run 1. And that's the little triangle that we were working with yesterday, a little slope triangle. As soon as you've got 2 points, that's really enough to create a line. Of course, the slope is going to be consistent throughout the course of that line. From here, if I rise 3, I'll have to run 1 and I'll get to the same spot. If I pick from here to there, I might be rising 6 and running 2, but 6 over 2 is still 3. Okay? So that's the idea. Let's graph the second line. So where is it going to cross the axis? 2. So we're going to start there. And how far up am I going to go from that spot? Up by 1? Over by 2. Something like that, right? So this line's going to be a little flatter. So the bigger this number is, the bigger the slope is, the bigger the growth factor is in your pattern, the steeper your line's going to be. The smaller it is, the flatter your line's going to be. The next one we have a negative slope, so instead of going up, it should go down from left to right. Where should I start though? Got it? And from 1, I'm going to go not up 3, but down 3. So 1, 2, 3. That's 3, right? And over how many? 5. Notice, when I'm going over, am I ever going to the left? No, I'm never going to go to the left. The negative, you always want to attach to the top or the vertical component. And either rise or fall, you always want to go to the right. That'll save you lots of trouble if you think about it like that. So there we go. This line looks like that. It's kind of a medium steepness. That should make sense because 5 over 5 would be the exact medium steepness to obtain 45 degrees for your line. Okay? Yeah. So pretty simple, right? After the last couple days. Let's take some lines that don't look like mx plus b and make them be mx plus b though. That's what I don't think you guys have done anything with yet. So let's just take a couple other examples. So let's say we had a line that looked like this. X plus 6y equals 18. And then let's look at the line, I don't know, negative 2x plus 4y equals 24. And we'll try those ones first. So those aren't in exactly y equals mx plus b form, right? They're a little bit mixed around. So you need to do stuff to them to make them be y equals mx plus b form. So I need to, in other words, solve for y. So this is our first little foray into solving stuff. I'm sure you guys did it a little bit in previous classes. We're going to go into it much harder this year. This is our first little taste of it. So if I want to get this y by itself, what stuff do I need to move? I need to move the 6, and I also need to move the plus x, right? So if you remember, the best way to do that is to move that x, the thing that's not attached, do that first. So if x is being added, how do you get rid of it? Subtract it. So minus x. In all equations in algebra, the fundamental rule is that if you do something to one side in order to balance the equation, you have to do it to the other. So if I subtract x here, I have to subtract x on the other side. Okay, you guys want to take nice thorough notes on this because it's the first time we've done it. Very important. So over here, the x's will go away to 0. And on this side, we have 18 minus x. These are not like terms, right? 18 and x are like apples and oranges. You can't put them together. I still don't have y by itself, though. I still have a 6 there. How do you get rid of that 6? Division, exactly. Very nice. This is multiplying the y. To get rid of division, you divide. I mean, rid of multiplication, you divide. If I do it on one side, I've got to do it to the other. I've made a mistake. I did not follow the Old Testament rule. I like to think of it biblically. It's like the most fundamental part of algebra. If you do something to one side, you have to do it to the other. But I thought I did. I didn't do it to all of the other side. That's all of the other side now. You guys get me? So make sure you do it to all of the other side. That's big, big time. Gonna keep coming up. Okay, so now this cancels out. We get y, nice. We'll have mx plus b, hopefully. So over here, what's 18 over 6? 3. And what's negative over negative? Positive. And that's a 1, right? We could stick a 1 in there if we wanted to. So it's like positive 1/6 x. That's how I write that. Okay. Now this doesn't say mx plus b. It's kind of like the mx is over here and the b is right here. You can turn it around if you want, but you don't have to. It's kind of the same thing. Why waste the time? The key is, can you guys read that and tell me where to start? Do I start with the 1/6 or do I start with the 3?
Start with the 3.
Yes, I start with the 3. Very nice. You guys are getting it. So the thing without an x coefficient is the thing that's the y-intercept, right? That's the b. And then I go from there where? Up 1 over 6, you got it. So this is a very flat line. Okay? There you go. Let's do 2 more. So this guy, you guys tell me what to do this time first. I want y by itself, right? You want to add that whole chunk. You're moving the whole chunk to the other side. So what's left? 4y. You can't put these together, so we've just got this.
Now you're going to divide 4.
Yep.
Yeah, you got it.
Everywhere. 6. 2/4 reduces, doesn't it? 1/2 x. And you notice how I put this x from like being on top there, I put it next to it. I think that's the way you want to go with these, okay? So now that line we should be able to graph. Let's see. So up 6. And again, we have kind of a flat line. I need to pick a wider variety of examples here. So let's do one more. I'll try to make this one come out a little different. Let's see if I can be successful. So we're going to go negative 5y plus 40x equals 60.
Oh, I was just thinking that.
Yeah? Okay, same process, right?
Yeah.
Add minus 40x.
You guys agree with Cheyenne? She's going for like the second part, not the
No.
first part.
Plus 5y plus 5y.
You could do either one, right? Both of those things are legal. But what are you trying to get by itself?
Why?
Y. So if you add 5y to the other side, you're just like moving that 5y, and then it'll have 60 by it, and it'll still be jammed up.
So
Why would you add
constable
40?
minus 40.
I think she wants to move this because remember, you're trying to get stuff away from that y, and this is stuff by
But
it.
then you'd still have the 5.
Right, but we're going to do that separately. If you add the 5y to this side, then you're going to have 60 plus 5y, and you'll still have your 5.
But it'll still be with the y.
True, and you don't want it with the y.
Right, so then why would it make a difference whether or not we leave it or move it? If it's still going to be the same in the end.
Because I'm getting rid of this first, and then I can get rid of that. You need to get rid of two things no matter what here, so. There are different ways to approach it, but this is going to be the fastest and most choice. And very good questions. So we've got negative 5y, these don't combine. And yeah, now we got to get rid of that negative 5. How do I do it, Maria?
You add 5y.
Is this adding to the y? Is this subtracting to the y?
No.
What's it doing?
Multiplying itself.
So how do you get rid of multiply?
So divided by 5.
There you go. Nice. That's what you got to ask yourself. What is it doing to the y, and do the opposite? So negative divided by positive, or positive over negative is negative, right? 5 goes into 60, I think, nicely. How many times?
12.
To 12, okay. And the negative over negative is positive. 40 over 5 is 8. So yeah, I think I succeeded in creating something a little different here, right? Where are we going to go and plot this point? Negative 12. Nine, 10, 11, 12, about right there. And, ooh, that's not a fraction. See, you like your slopes to be fractions, so I need to make it a fraction by putting a 1. So I'm going to go from here up 8. What's 12 plus 8? Or, negative 12 plus 8. 4, right? So it's going to go up quite a ways. Until about right there. Over 1 only. This line is very steep, and that's because it's growing by 8 every 1 unit. If this was a tile pattern, going back to the last couple days, there'd be 8 extra tiles every figure. Does that make sense? So it'd get really big really fast. You guys think you got it?
Yeah.
All right, nice. We'll see you next time.